So the I can statement for 9.5 is I can understand and perform compositions of transformations. So let's write the word compositions. Compositions of transformations. Let's remind ourselves of the four transformations that we worked with. We did translations, reflections, rotations, and dilations. And in part A it says which transformations are rigid transformations. So remember, rigid means it's going to be the same size and shape of the figure. That hasn't changed, but maybe it changed orientation. Maybe it points a different direction or something like that. So translations, all we did with those is we slid them around, took the same shape and slid it around. Reflections, we reflected across a line of symmetry. Rotations, we rotated it or we turned it around a point of symmetry. And dilations, that's where we stretch or shrink, so that is not a rigid transformation. Translations, reflections, and rotations, those actually create congruent figures. And then it says which transformations make similar figures. Well, these all make congruent figures. Translations, reflections, and rotations make congruent figures, so we probably wouldn't include those. But dilations, those make similar figures unless, so let's go ahead and write unless we did something weird like this. So let's say the new xy point was 4 times xy and then negative 3 times, or sorry, 4 times x and then negative 3 times xy. If it was something weird like that, we're doing some crazy stuff with that. That's not going to be stretched the same amount in each direction. And the last part of the warm-up here, what does the word prime mean? Prime means new. And we're actually going to see a different type of prime notation as we go through today's assignment. So we're putting all of these together, and we'll talk about what a composition of transformations is in just a second. So let's remind ourselves what a translation is. A translation is basically a slide. We're going to slide the same figure left, right, up, or down, and maybe a combination of those. So right is positive, left is negative when we're changing the x coordinate by either adding or subtracting. That adding or subtracting is what slides it around in the x direction. We could either add or subtract, add to go up or subtract to go down k units depending on the sign. So notice the x doesn't change at all, but the k, we're going to add or subtract k units. Adding is going to move it up, subtracting is going to move it down. And we can also do more than one. So we could have x plus minus h and y plus minus k. We could combine a couple of those together in order to change it both horizontally and vertical in the x direction and the y direction. So be sure to keep straight which is the pre-image and which is the image. So I'm going to write this down. I'm going to write down new here, and I'm going to write down, whoops, other way around. This is the old one, and you can tell because this doesn't have the prime notation on it. This one does. So this one is the new one, and we want to write down the rule here. So you notice the shape is exactly the same. All that happened is they slid this L over to the left and then up. So let's count how far it went to the left. 1, 2, 3, 4 units to the left, and then up 1 unit. So that means they're going to take each x coordinate and they're going to subtract 4 from it. That would move it to the left. And then they're going to take each y coordinate and they're going to move it up 1. So that's going to be plus 1. So that's an example of a translation, a slide. Let's talk about a reflection. A reflection is a mirror image. Mirror image across a line of symmetry. Now we had a whole bunch of lines of symmetry that we used. There were 4 of them in fact. The first one was y equals x. If it's a reflection across the line y equals x, then the x and y simply switched places. The x and y just switched places. What used to be the x was now the y, and what used to be the y is now the x. If we reflected across the line y equals negative x, so just to make sure we're clear on this, we're talking about reflecting across this line, and on this one we're reflecting across that line. So what happens on this one is we switch the x and y, and we also change the signs. Then if we're going to reflect it across the y-axis, the x is the one that changes coordinate. Okay, so we're reflecting across this line right here. It's the x that changes, so we're going from left to right or right to the right to left. And then if we're going to reflect it across the x-axis, we're flipping something from the bottom onto the top or the top onto the bottom. So you'll notice as we do that, we're moving in the vertical direction. So what happens here is this is going to be x and then negative y. We're going to change the sign of the y coordinate. So on the example it says draw the line of symmetry and write the function. So let's take a look here. And one way that you could tell what line we're reflecting this across, what the line of symmetry would be, is if you draw a line between B and B prime, G and G prime, and this is Z and Z prime. We want to find a line that goes right through the middle of here, and it's got to be perpendicular to each one of these. So that's going to be this line right here. So that's going to be the line y equals x. So it's a reflection across the line y equals x. There's our line of symmetry. And a reflection across the line y equals x, all we do is we switch the x and y. So this is going to be y here, and this is going to be x there. That would take care of that reflection. Let's talk about a rotation. So when we talk about rotations, the ones that we do, we're always going to be rotating about the origin. So the origin is that central point, and what that means is we're going to turn the image around that central point, and again, like I said, usually the origin. So we've got 90-degree clockwise rotation, 90-degree counterclockwise rotation, and 180-degree rotation about the origin. Again, we don't need any direction on that one, clockwise or counterclockwise, because it just ends up in exactly the opposite direction. That's what we mean by 180. So if we're going to do a clockwise rotation, the x and y switch and the x changes sign. If we're going to do a counterclockwise rotation, the x and y switch and the y changes sign. And if we're going to rotate it about the origin, here's the cool part, they stay in exactly the same place. They just change signs. So what used to be an x is now a negative x. What used to be a y is now a negative y. So if we take a look at this one right here, let's see what's going on with this. This is a rotation of some sort. It wouldn't be in this example right here for rotations if it wasn't. We're always rotating about the origin, and we gave one way that you could tell what's happening here. If you draw a line from the new one to the old one through the origin, you can kind of see what's going on here. So this one would go right up there. So this is a reflection, or sorry, a rotation of 180 degrees. We spin H around here, we spin K around here, and we spin N around here. Or you could go around the other direction. It wouldn't matter whether we went clockwise or counterclockwise. So this is going to be a 180 degree rotation. And again, we could say about the origin if you wanted to, but all of the ones that we deal with, we're going to be rotating about the origin. And so if we come over here, remember, this is the one where the x and y stay in the same place, but they do change signs. Okay, so that would be the rule. That's the function or the mapping that does a 180 degree rotation. And dilations, these are where we either enlarge the figure or reduce the size of the figure. We used kind of simple terms like stretch or shrink. Stretch or shrink. Stretch means it gets bigger, shrink means it gets smaller. So a dilation with a scale factor of c, here's what we do. We take each one of the coordinates, the x and the y coordinate, and we just simply multiply each one of them by whatever the number is. So if we're multiplying by a number that's larger than 1, then the figure gets stretched, it gets bigger. Okay, so I'm going to write bigger over here. It gets bigger. And if c is less than 1, if the scale factor is less than 1, then the figure gets shrunk. In other words, it gets smaller. Okay, so let's take a look over here and see what's going on. It says identify the scale factor of the dilation, so it tells us it's a dilation, then write the function. So if you'll remember, all we need to do is figure out what the scale factor is here. This one is the old one, so I'm going to write old here, and this is the new one, and I'm going to zoom in on this one so we can see what's going on. Because this one has fairly small numbers. Quick reminder, I think we actually did this one in the notes, but if you take a look at this, you'll notice that h goes to h prime. This is a nice point, but this is not as nice because it's in between these two values right here. This is not a nice point, so we probably don't want to use g and g prime. Let's use f and f prime because those match up with each other. So remember, it's going to be the new over the old. So we're going to take the new coordinate right here. So take a look at this one. This one is 2, 2, and this one is 4, 4. We're going to take the new one, 2, over the old one, 4. So this would be 1/2. This right here is our scale factor, and you'll notice that it's basically becoming half the size. So this would be 1/2 x, and this would be 1/2 y. That's going to shrink all of the coordinates there. So we've got all 4 of the transformations covered here. This is what we did. We did all 4 of those. We've got an example of each one of those along with all of these rules, all of those mapping functions that tell us how to change the x's and y's to make that transformation. Now, you don't have to memorize every single one of these, but you should be able to recognize them and be able to carry one out if they're given to you. So if you take a look at example 1, it says, is this rigid or non-rigid? Is it similar or non-similar? So the rule says do this. Take xy and map it onto negative 2x and then y plus 2. Well, the first thing we notice is this one is being multiplied by a negative 2, and this one is, all they're doing here is adding. So this is going to change the x coordinates by making them the opposite of what they were before and 2 times bigger. So there's no way if we multiply it by a number that it's going to be non-rigid, or sorry, rigid. So it's going to be non-rigid. It's actually going to change the shape. So change shape here, okay, or at least the size in the x direction. And then similar or non-similar. Well, if we're doing different things, it's not going to be similar. Maybe if we had multiplied both of them by negative 2 or something like that, that would work. But definitely non-similar here. Now let's talk about what a composition of transformations is. So a composition or compositions of transformations occurs when we perform 2 or more transformations. So let's write the word transformation here. Transformations in a specific order. So we're going to do a couple of examples. So all we're doing is when we compose a letter, we write a bunch of words together. When we compose transformations, we're going to string together several transformations, and we're going to see what the end result is. Now on some of the ones on today's assignment, all you have to do is take a point. So let's take this point right here. The point A is negative 2, 1. So we're going to graph that over here. So we're going to go to negative 2, 1. So that's the point A. All right, that's the original point that we're working with. So we're going to carry out these transformations. We're going to do a translation and then we're going to do a reflection. So it's got the information about the translation and then it's got a description of the reflection. And it says this in the instructions. It says use prime and double prime notation. Now here's what we mean when we're talking about prime and double prime notation. The first time we do a transformation, we're going to get a new point. That's the first new point, so we call that prime. And then if we put 2 of them on there, that means we did 2 things to make like 2 new points. So we kind of go through the process. If we get 1, we only do 1 prime. If we do 2 transformations, we do double prime is what we call it. If we did 3, we'd have triple prime and so forth. So the first thing we're going to do with this one is we're going to take it and we're going to do this transformation. We're going to take the x coordinate and we're going to subtract 2 and we're going to leave the y coordinate alone. So we're going to subtract 2 and we're going to leave the y coordinate alone. So that's going to make this, let's see, we get negative 4, 1. So negative 4, 1. So slide back 2, and notice that matches up here because this would be left 2. So we're going to slide back here and this would be a prime. All right, and then we're going to reflect it across the x-axis. Well, if we reflect it across the x-axis, this is kind of our line of symmetry. That's our mirror line. So we're going to take this and we're going to take it from 1 unit above that line of symmetry to 1 unit below the line of symmetry. So again, we count how many we are away from that line of symmetry and go directly across, kind of perpendicularly down here. So this would be a double prime. So here's what happens to that point. It started out right here. It was negative 4, negative 1, or sorry, negative 4, 1. That's a prime. A double prime would be this point. It would be negative 4 and negative 1. So negative 4, negative 1. I guess I don't need the equal sign on there. Okay, so this would be the end result. But as long as you've graphed this, that's what we're after. Graph the image of that point after these transformations are carried out. So if you wanted to write these down, that would be fine. Notice what happened here is we moved this back 2 units. Okay, so that would put us at negative 4. We subtracted 2. And then when we reflect across the x-axis, the y coordinate is the one that changes because all we're doing is we're still going back 4. It's just that instead of going up 1, we go down 1. Okay, let's take a look at the next one. Oh, it says, what similarities do you notice between the pre-image and the image, orientation, size, shape, or nothing? Now, because all we've got here is a dot, you really can't notice anything. The only thing that happened is it moved around. But as we do these compositions, keep this in mind. Take a look at the pre-image and the image and figure out, gosh, can I kind of see what happened here? Because you're going to have some on the assignment and maybe one on the test where you've got to look at it and figure out, gosh, what happened here? What did they string together as far as transformations go? Okay, it says the endpoints of CD are 0, 1, and 3, 4. Graph the image after the transformations are carried out in this order. So we're going to do 0, 1. So 0, 1 right here, that's C. And then D is 3, 4. So over 3 and up 4. So there's D. And it says we're going to do this transformation. We're going to take these points, and we're going to have x stay the same, but y we're going to add 2 to them. So we're going to add 2 here, and we're going to add 2 here. So that means C prime is going to be 0, 3, and that means D prime is going to be 3, 6. So 0, 3, so we're up here, so there's C prime, and 3, 6, so that would be up here. Here's D prime. So I should have connected the two of those, and we'll connect those. So here's the original, this is the pre-image, this is the old one, and here's the new one. This is the image after this first translation, and then we're going to do a reflection across the line y equals x. Okay, so let's go ahead and draw that line here. So I'm going to draw that line. And we can do this a couple of ways. We could look up what the rule is for that, or we can go through here and we can say this, and I'm going to change colors for this. If this is the line of symmetry, we're going to go straight towards that point. So notice what we've got here. We've got one full box going diagonally, and then we've got a half a diagonal box. So we're going to go half a diagonal box, and then we're going to go one full box right there. So that's D double prime. And then going this way, let's see, there's one full box right here diagonally, and there's a half a box. So we're going to go another half a box and then one full box right here. So this is C double prime. Okay, so here's what happened, and hopefully we can see this. We took this point and we slid it up, and then we folded this graph, and this lies right on top of that. So this D double prime and C double prime is the mirror image of C prime, D prime. Now, if we wanted to go back and look up the rules, here's what the rules say. If we're going to reflect across the line y equals x, we just switch the x and y. So this would be xy, and we would switch it to y x. So let's see what happens when we do that. So that means C double prime would be, C double prime would be 3, 0. We literally just switch them. And D double prime would be 6, 3. So let's check and see. 3, 0, there we are right there, and 6, 3, over 6 and up 3. So we're in good shape there. And again, the question, what similarities do you notice between the pre-image and the image? So this is the original one, and this is the final version of it. Do we notice anything about orientation, shape, size, similarity, congruence, or do we notice nothing about this? What you should definitely be able to see, even with points or lines, is you should be able to tell, hey, this slid up 2 units, and then we reflected it across here, especially telling the order. This is the original one. C prime, D prime is the first transformation, or after the first transformation, and then C double prime, D double prime is over there. Okay, let's take a look at one from your assignment. I think these will be a little bit more interesting. We're going to take a look at number 8 first, and then we're going to take a look at another one on here. So this is 9.5, compositions of transformations. I'm going to slide down here. You'll notice that we've just got some points that they ask you to move around. They are already graphed on there. There's some lines that they want you to move around. And then on this one it says describe the transformation in the correct order, and it says note the prime and double prime notation. So this is the old one, this is the new one, and this is the newest one. Okay, so old, new, and newest I'll put on here. Okay, so this is the double prime notation. So this is after they've done 2 different transformations. So let's see if we can tell what happened here. So this is the old one, and then they just took this and they created A prime, B prime, C prime. So what they did is they did a reflection. They did a mirror image across. This is the x-axis. So let's write that down. That is a reflection. So the first thing is a reflection across x-axis. Now, we don't have to write the rules for this or anything like that, so that's kind of good. So the first thing they did is they reflected it across the x-axis, and the next thing, you'll notice the orientation stays exactly the same for this one. All they did is they took A prime, they moved it up here, B prime moved it up here, C prime moved it up there. They slid it around, so that's a translation. So let's write translation. And that translation was, let's see what happened here. They moved it 1, 2, 3, 4, 5, 6, 6 units to the right, and then up 2. So think about what happens here. 6, let's write it this way. Let's do right 6, and then up 2. You'd be doing really well if you could write down a rule that would do that, a function that would do that. That'd be pretty awesome. Now I'm going to slide it over to the other side, and we're going to take a look at problem number 16. Now 16 through 19, what they do is they ask you to match the composition described with the diagram below. So it says translate whatever the figure is parallel to line L, then reflect it across line L. So let's take a look at what happens here. This is the old one, this is the new one, and this is the newest one. Again, you can tell by the A prime, and the A double prime. So if we take this figure, how do we go from this one to this one? So that would be kind of a little rotation here. Looks like a clockwise rotation this way right here. All right. So that would be a rotation. So that's not what we're after here. We didn't have any mention there. Translations. So we're going to slide things parallel to this right here. So this is A. Let's see what happened here. The first thing that happened on this one is probably, notice it's not a reflection, that's probably a rotation also. So to have it pointed up like this and then down like that, that's got to be a rotation. So that one's not ours. A and A prime. This one says we translate, so we slide it first. This looks like the first thing they did was a reflection, and then maybe a translation or something like that. Okay, but we don't have any reflections on this one. We've got a translation, so a slide. So look at A and A prime. The first thing they did is they slid it down here, and again they slid it parallel to line L, so that looks pretty good. And then did they reflect it across line L? They did. So I think on 16 the answer on that one would be D. And again, what we're looking for is, can you recognize what's going on in these compositions of transformations? Okay, this actually is, we've done a couple from your assignment. This is what it looks like. So I'm hoping that you're in good shape for this. Good luck on 9.5.